Okay, communication systems. So this is an easy topic where which we are going to secure 100% one question in any competitive exams at least. So first we will think of communication. We will think of the meaning. Communication is the act of is the act of transmission is the act of transmission and reception of information. So that means we will transform the information from one place to the another place, and we will deliver uh, to the required persons. Actually, for successful communication, we need some factors, or we need some persons. So we will see for successful communication, we need the sender and receiver and a common language. A common language that can be understood between the sender and receiver we need. So the most important point of a communication system is the block diagram. So we will see the block diagram of communication systems. Block diagram of communication systems we will see. So in the block diagram, so we have several steps. So first one I'm taking information source. And after that we have transmitter. So after that we have channel. And after that we have receiver and user. So that means the receiver. So he has information finally. So we will take the different parts of the block diagram. So let us see how they will work and how they carry forward the information from the source to the receiver. We will see. The receivers have user information. First, actually, from the information source, a message will be passed. So that message will be in the form of a signal. So into the transmitter, it is used to send to the transmitter. So after the transmitter, so the duty of transmitter is to transmit the signal. For example, this is the transmitted signal. And this channel means the platform through which we are sending the signals. So there we have unwanted noise also get added with the signal. So this channel will send the signal to the receiver. Receiver signal we are writing here. So this receiver again it will convert that signal to message. It will convert the signal to message. So now I will explain. So information source. Suppose if you are interested to chit chat with a friend who is very far away from us. So we are the source. Okay, we are the source. So we will send the message. That means audio message, or it may be online call, or whatever it may be. So we will send a signal. So actually, that message. Suppose if we talk with our friends, so the communication will not be carried forwarded as audio signals. అంటే మన ఫ్రెండ్స్ తో మాట్లాడితే అది ఆడియో సిగ్నల్ గానే క్యారీ ఫార్వర్డ్ అవుతుంది. ఎందుకని అంటే ఆడియో సిగ్నల్ గా వెళ్ళాలి అంటే మాక్సిమం ఎంత ట్రావెల్ అవుతుంది? ఫర్ 1 సెకండ్ ఓన్లీ ఇట్ ఈస్ ఏబుల్ టు ట్రావెల్ అప్ టు 330 meters. అంటే 1 kilometer రీచ్ అవడానికి 3 seconds పడుతుంది. బట్ మనం యుఎస్ లో ఉన్న ఫ్రెండ్ తో మాట్లాడాలి అంటే may take place. సో కాబట్టి ఇక్కడ యాక్చువల్‌గా ఏం చేస్తారంటే వైల్ వి ఆర్ కమ్యూనికేటింగ్ విత్ అవర్ ఫ్రెండ్స్ దట్ ఆడియో సిగ్నల్ ఈస్ కన్వర్టెడ్ ఇంటూ సమ్ డిజిటల్ సిగ్నల్ బై యూజింగ్ ఎ డివైస్ కాల్డ్ యాస్ ట్రాన్స్‌డ్యూసర్. సో అదేం చేస్తుంది అంటే ద ట్రాన్స్‌డ్యూసర్ ఈస్ ప్రెజెంట్ ఇన్ ట్రాన్స్మిటర్. It will convert the audio signals into some message. So that message will be in the form of a signal. So it may be a digital signal and it is sent to the transmitter. అంటే మన ఫోన్లో ఉండేటువంటిది దీన్ని మనం ఏమంటాం అంటే ట్రాన్స్మిటర్ అంటాం. సాటిలైట్ ఫోన్స్కి అయితే డైరెక్ట్గా ఒక ఏరియల్ లాగా ఉంటుంది, అదే ట్రాన్స్మిటర్ అనుకోవచ్చు. లేదా మనం మొబైల్ కమ్యూనికేషన్ గురించి మాట్లాడితే మాట్లాడిన ఆడియో సిగ్నల్ కాస్త డిజిటల్ ఫామ్లోకి వెళ్ళాక ట్రాన్స్మిటర్ అంటే మన నియర్ బై సెల్ ఫోన్ టవర్ మనం తీసుకోవచ్చు. It will transmit the signal, it will sense out the signal. So channel means we have path, we have by what medium you are sending the signal from one place to the another place. So here channel means we will take the help of satellite. ఇక్కడ మనము తీసుకున్న present example లో satellite ని ఛానల్ గా మనం తీసుకుంటూ ఉంటాం. So that means whatever may be the communication that we have passed to the nearby tower, and that nearby tower will send the signal to the space. Channel అంటే ఇప్పుడు మన మొబైల్ కమ్యూనికేషన్ లో స్పేస్ కి పంపిస్తుంది. So again that signal will send back to the earth and it will reach a location where the receiver is present. So there also we are having towers. The towers will receive the signal, okay, and the towers will they will convert that signal into our required signal form. So finally it reaches the user. So we are having this kind of several steps during a communication. Now we have two basic models. We have two basic modes of communication. We have two basic modes of communication. So one is the first one is point to point. First one is point to point, and the second one is broadcast. Point to point means so generally we have single transmitter and single receiver. Single transmitter and single receiver. Suppose if we are chit-chatting with our friend, so we will become the transmitter and he or she will become the receiver. So in that case it is called as point-to-point communication. When we think of broadcast, suppose if we observe television broadcast, so we have single transmitter and we have many receivers, single transmitters and many receivers. So this is the example like for TV broadcast. So we will take that. So now we will understand what do you mean by signal. So signal means it is a single valid function. It is a single valid function of time. It is a single valid function of time that carries the information. Single valid function means maybe 1 or 0 like that. That carries the information. Generally, it is usually in the form of voltage. It is usually in electric form. That is voltage we are speaking. And we have generally two types of signals are there. So first one I am taking analog signal. So the signals are divided into two categories. One is analog signals. the current or voltage which changes continuously with respect to time, continuously with respect to time. Best example is monitoring uh, ICU room of a hospital. సో మనము హాస్పిటల్ ఐసీ రూమ్ లో చూస్తే ఒక మానిటర్ ఉంది, దాంట్లో several values will be displayed. So that means oxygen saturation and the BP level, everything we are going to see from a screen. So you will get a curves like this. You will get a curves, random like curves. So we are having random like curves. So that means the voltage goes on changing with respect to time. So that is called as analog signal. Suppose if that is sinusoidal, we are taking E equivalent to E naught into sin omega t plus. So when we think of the examples for the analog signals, we may take speech or we think of music. Because we have different variations. We have different variations in the signal. So that is about analog signal, and we used to think of digital signal. Digital signal. So digital signal is nothing but it is having some kind of discontinuation. It is not continuous. Digital signal is the discontinuous function of time. Suppose if you are interested in a graph, so then we will say this is the y-axis and the respective x-axis. Suppose if you have the digital signal, the digital signals will be like this. So this will be of digital signal. So this is the time and this is the EMF latest. So when we think of example of the digital signal, so this is nothing but output of digital computer or else we will take facts. So this is about the digital signal. And just now we discussed about the term transducer. So transducer means it will convert one form of energy into other. For example, in our mobile phone, suppose if this is a mobile phone, so we have this is the speaker. That speaker is connected to the transducer. So what is the duty of the transducer is it will convert here audio signal into digital signals. So actually it is a small part of microphone. Okay, so that's why we will take the example as microphone in our mobile converts speech sound signals into electric sounds. And we will understand one more thing is noise. Noise means a kind of disturbance. Noise is nothing but a kind of disturbance we are taking. It refers to the disturbance or distortion, disturbance or distortion in transmission of the signal. So generally the noise is present. The noise may be due to imperfections of the channel. Imperfections of channel. So we will take the next one is transmitter. Because before studying the problems, so studying about all these things are very, very important, very, very crucial to understand the formula. And very, very important to understand the question itself. Transmitter means it converts message signals. It converts message signal to suitable form, to the required suitable form for transmission. Suitable form for transmission. So after that, after transmitter, so we used to think of receiver. Receiver means who receives the signal. Receiver means who. It is a device which pick up or picks the transmitted signal, which picks the transmitted signal at the channel output. At the channel output. So that means the person or the device who receives the signals at the end of channel output and process it to reproduce message signal into suitable form. So we are taking this is receiver. So next, when we think of the process of communication, generally some loss of energy will take place. So that is called as attenuation. So attenuation means this is the loss of signal strength, during its propagation through communication channel. So this is about attenuation. And next we think of amplification. Amplifying means increasing the strength of signal. So that means this is the process of increasing the strength of transmitted signal. So the upcoming one is important, range. So generally we will come across in these problems, range. So range means this is the largest distance largest distance between transmitter and receiver. Between transmitter and receiver. Between the transmitter and receiver. So after taking the range, we will think of bandwidth. So these terms are very important to understand the problems. Bandwidth. So bandwidth means the range of frequencies, over which communication system works. Over which communication system works. So then we will think of modulation. So modulation means the phenomena of superimposing the low message signal, superimposing the low message signal, low message signal to high frequency wave, So that high frequency wave is called as carrier wave. So actually, while we are talking, we will, of course, the transducer, it will convert into digital form. So that is message, still it is message. That message is superimposed with a carrier wave. ఎందుకంటే ఆ డిజిటల్ ఫామ్ దానికి ఎక్కువ ఎనర్జీ ఉండదు. సో ఆ సిగ్నల్ని మనం మాట్లాడడానికి ఎక్కువ ఎనర్జీ ఉండదు. సో దాన్ని మనం పంపించాలి అంటే ఇంకొక వేవ్తో సూపర్ ఇంపోజ్ చేస్తాం. సో ఏ వేవ్తో అయితే సూపర్ ఇంపోజ్ చేస్తామో దాన్ని మనం క్యారియర్ వేవ్. Actually, this process is known as modulation. Modulation means modulation. This process is known as modulation. This process is known as modulation. So next, demodulation. So before understanding demodulation, first again we will discuss modulation. Modulation means addition of message signal to the carrier wave. So demodulation means it's opposite, it's contrary. So that is the phenomena or the retrieval of information. From modulated wave. At the receiver. So this is about modulation. We will think of. This is about modulation. And at the end, in the basic terminology, at the end we have a term repeater. So generally we will see the repeaters on almost over the top of the buildings. We will see beside the cutouts. మనం చూస్తుంటాం రోడ్ మీద ఈ షేప్ లో ట్యూబ్లైట్ షేప్ లో మనకు కనిపిస్తూ ఉంటాయి. Near the hoardings, or we will see in our streets. Over the buildings we will see. Towers is different. These are repeaters. So that means they will receive the transmitted signal. They receive the transmitted signals, amplifies it properly, amplifies it properly, keeping its original form, keeping its original form, then relays, that means transfers it into next repeater. అంటే ఇక్కడ రిపీటర్స్ అంటే ఏంటో చూద్దాం. For example, when we are thinking of mobile communication, this is the tower, let us say, this is the tower. So the tower is very far away from our home. So let us take this is our home we are taking. So actually between that tower and as well as our home, we have a small tube-light like structures are having over the building. So they used to call as repeaters. So that means what they will do is they will receive the signal and they will amplify it, they will amplify it and they will send it to the required person, send it to our home. So this is about repeater. Okay. Next, we have been thinking of media. So media means it is the medium by which we will send the signal. It is the medium by which we will send the signal. So one is guided, guided media, guided media, and we have one more unguided media, guided media, and as well unguided media. So here guided media means generally we have point to point, point to point. From point to point, the medium is present. So unguided medium means we have single transmitter, and large receivers. We have many receivers. So now again we will explore this. So point to point means we have basically we have three categories we are taking. So one is coaxial cables, and the other is twisted pipe cables, and the last one is coaxial cables means generally for example I am taking, so TV, we connect the TV with a wire, TV wire or TV cable, that is called as coaxial cable. So when we open that cable, generally we are having a central cable, so it is surrounded by some white cable, uh, white fiber material, and that fiber material also సరౌండెడ్ విత్ కేబుల్. మనము టీవీ వైర్ని ఓపెన్ చేస్తే సెంటర్లో ఒక కేబుల్ కనిపిస్తుంది, దానిపైన ఒక ప్లాస్టిక్ ది ఫైబర్ లాంటిది కనిపిస్తుంది, దానిపైన మళ్ళీ ఒక wounded లేయర్ అనేది ఉంటుంది. సో because they are having common line, common cable, that way it is called as coaxial cable. Next, twisted pipe cables means generally we will come across these twisted pipe cables, especially for home theaters. Home theaters. For home theaters, the wires which are connected between the speakers, they are twisted pipe cables. OFC means all of you know this optical fiber communication. So by through this only we will send the signal from one place to the another place on the road. మనం చూస్తూ ఉంటాం. So on the road sides we are having OFC cables. So generally they will transfer the digital signals, like we are using internet and as well mobile communication. So that also happens by OFCs. OFCs means we are having the pipes filled with cables. Okay, that is known to everyone. So next, when we think of unguided medium, we have radio waves and we have microwaves, and the end we are having satellite. So that is known to everyone, single transmitter and number of receivers we are having. Now we are going to discuss the most important parameters. So that means the most important parameters and values we need to memorize. And ఇప్పటివరకు మనం చేసుకున్న discussion అంతా, so these are the basics. These are the basics to understand the problem. But from now onwards, you need to be understood it very carefully because we need everything from here. Everything is very important. So you need to memorize the values and as well as formulas. Suppose when we think of speech signals, so they have a frequency range. So we will call speech signals, they are having 2800 hertz. They have a frequency range. So when we think of music signals, they have a frequency range up to 20 kilohertz. When we think of video signals, they have a frequency range up to 4.2 megahertz. When we think of TV signals, 6 megahertz we are writing. And when we think of coaxial cables, they carry the information up to 750 megahertz. So optical fiber cables, this is very important. They carry the frequencies from 1 terahertz to 1000 terahertz. So here 1 terahertz equivalent to 10 power 12 hertz. FM broadcast is 88 megahertz to 108 megahertz. చూడండి, కావాలంటే మనం వినే అన్ని ఎఫ్ఎంలు 93.6 ఎఫ్ఎం, 92.7 ఎఫ్ఎం, సో ఈ అన్ని ఆ ఫ్రీక్వెన్సీ రేంజ్లోనే ఉంటాయి. FM broadcast 88 megahertz to 108. So these values are very important. You need to be memorized. So the questions will be directly asked. What is the frequency range of video signal? Hello, direct questions. So you need to be very careful in understanding the thing. So next we are taking various modes of propagation of EM waves. Various modes of propagation of EM waves. So first one, we are speaking about ground waves. First one, we are speaking about ground waves. So ground waves, in the name itself, we have the situation clearly. Suppose if this is the earth, so that means that these waves, they travel. Suppose we are taking this as the earth. So along the surface of the earth, they will travel. Along the surface of the earth, they will travel. Along the surface of the earth, they will travel through atmosphere. So I'm taking the definition. The radio waves which travel through atmosphere following the surface of the earth, like radio signals, are known as ground waves. This kind of transmission becomes weaker with increase in frequency. With increase in frequency. This kind of transmission becomes weaker with increase in frequency. అంటే మనం హై ఫ్రీక్వెన్సీ వేవ్ ని పంపిస్తున్నాం అనుకో, ఆ హై ఫ్రీక్వెన్సీ వేవ్స్ ఏమవుతాయంటే దే ఆర్ యూస్ టు బి అబ్జార్బ్డ్ బై ది గ్రౌండ్ because more absorption of these takes place. More absorption of these takes place by the ground, by the earth. So that's why, therefore, it is not suitable for high frequency communications. So that's why we have a limited range, and these numerics are very important for any competitive exam. So this technique is valid. This technique is valid for low and medium. For low and medium signals, low and medium signals. That is up to 2 or 3 megahertz. Up to 2 or 3 megahertz we are speaking. So we need to memorize these values. So because they are very important, the questions will be directly asked. So next, I have been speaking about sky waves. So next we are taking sky waves. Because sky waves means generally in the name itself there we have the complete wave propagation to the sky only. Their range are, so that means their frequency range, allowable frequency range is 2 megahertz to 30 megahertz. 30 megahertz. And here ionosphere, this is very important point. Ionosphere acts as reflector for these waves. So that means if this is the earth, on the earth we are taking, this is the transmitter and this may be receiver. So the waves which are emitted from the transmitter, they travel up to ionosphere. And they get reflected back to the receiver. So this generally takes place during the propagation of sky waves. And the transmitter means certain waves ionosphere daaka velli malli reflected receiver daaka vastayi. And the electromagnetic waves greater than 30 megahertz. So what about if we send the more high energetic waves through the sky? What happens? Let us see. So the EM waves which are having more than 30 megahertz can penetrate through ionosphere. సో అవన్నీ ఏమవుతాయంటే ionosphere నుంచి వెళ్ళిపోతాయి. సో మనకు యూస్లెస్ అన్నమాట. And the last point is very important. So the allowable frequency is F equivalent to 9 into root of n max. So here n max is the maximum electron density of ionosphere. Maximum electron density of ionosphere. So after this we are taking space waves. So in the name itself there we have the total information. So that means these waves can propagate through the space. Their frequency range is, we are speaking from 30 megahertz to 300 megahertz. 30 megahertz to 300 megahertz. So therefore, they can travel through atmosphere. They can travel through atmosphere. Atmosphere from transmitter to receiver directly, or reflection from troposphere, or by reflection from troposphere. These terms are very important. Troposphere. And these space waves have another name. They're also called as line of sight communications. Line of sight communications. So why? Because we have taken the last point, that is, they will some signals may directly transfer from transmitter to receiver. ఇక్కడ మనం తీసుకున్నాం ఏమని అంటే they can travel through atmosphere from transmitter to receiver directly. So directly they can transfer from transmitter to receiver. So this line is called as line of sight. అంటే మనం చూసేటువంటి లైన్, మన కంటి చూపు ఉండేటువంటి లైన్. సో దట్ ఈస్ లైన్ ఆఫ్ సైట్. అంటే ఇలా స్ట్రైట్ లైన్ డైరెక్షన్ లో వెళ్తున్నాయి కాబట్టి వీటిని లైన్ ఆఫ్ సైట్ అంటారు. సో here only we have very less formulas, but out of that less formula, the first formula, the most important and beautiful small formula is range. Range of any tower. It may be transmitter or receiver. Range of any transmitter or receiver, whatever it may be. So we have D equivalent to root over 2RH. So D equivalent to root over 2RH. So first we will understand what do you mean by the range. Suppose here I am taking, this is an antenna. It can sense out the signals. So then through what distance it is able to communicate, or it is able to spread out that communication. So simply that is called as range. So that is called as range. So next one we are taking the maximum line of sight distance, between two antennas. So one is transmitter and other is the receiver. Two antennas of heights HT and HR. For example, we have a tower called as transmitter and we have another tower called as receiver. Just now we have studied, so it is able to emit the waves and it is also able to emit the waves. It is able to receive the signal and this is also able to receive the signal. So that means simply we will say this will be the DT, so that is the range of transmitter, and this will be DR, so that is the range of receiver. Okay, the maximum line of sight communication distance between the two antennas of height HT and HR is D max equivalent to root of 2R HT plus root of 2R HR. So here Kepler means radius of Earth. Radius of Earth we have been speaking. So it is equivalent to 6,400 kilometers. And the next one is important. Area covered by any antenna. It may be transmitter or receiver. Generally, we are speaking. Area covered by the antenna. So that means communication area covered by the antenna. So that A equivalent to pi d square we are taking. As d equivalent to root of 2rh, we are taking pi into 2rh. So where we know that h is nothing but height of antenna. Height of antenna. And the next important principle we have been speaking, that is population covered. Population covered. Population covered equal to population density into area covered. Population density into area covered. So this is also very important thing. And next one is, we used to think of antenna. We used to think of antenna. So antenna means a metallic object. So it may be often a wire or wires. So we know about antenna. In the olden days, we are having TV antennas like this. Now onwards, now also uh, we will see this kind of antennas over police stations. Over police stations and some hospitals, we will see this kind of towers. So those are called as antenna, a wire or wires. This is used to, antenna is used to both send and receive, radio frequency signals. And we have a formula for size of antenna. So clearly speaking, this is minimum size of antenna. Minimum size of antenna equal to lambda by 4. Lambda is nothing but wavelength of signal. So signal means we may get confused because we are having two waves. One is message related wave and the second one is carrier wave. So this is important. Wavelength of carrier wave we are taking. And we are taking the important formula, the power of antenna of length L. That is P is proportional to L by lambda whole square. So that means as the lambda is less or the frequency is more, so automatically the power will be more. So these are the very important terms regarding the communication system basics. So next we are going to see the real part of communication system, that is about modulation. So we will think of mixing up of signals from different transmitters. అంటే ఇప్పుడు ఫర్ ఎగ్జాంపుల్ రేడియో స్టేషన్ తీసుకున్నాం అనుకోండి, మనకు అన్ని రేడియో స్టేషన్ సిగ్నల్స్ అనేవి ఓవర్లాప్ అయ్యే ఛాన్స్ ఉంటుంది. అందుకే ఏం చేస్తారంటే, ఫర్ ఎవ్రీ రేడియో స్టేషన్స్ వీ హ్యావ్ ఎ పర్టిక్యులర్ ఫ్రీక్వెన్సీ రేంజ్. ఫ్రమ్ దిస్ ఫ్రీక్వెన్సీ టు దిస్ ఫ్రీక్వెన్సీ వీఆర్ హ్యావింగ్ సిగ్నల్స్ ఫర్ లెట్ అస్ సే విజయవాడ రేడియో స్టేషన్. అలా మనకు ఉంటుంది. సో దాని గురించి ఇప్పుడు మనం చూద్దాం. వెన్ many people are talking at the same time, when many people are talking at the same time, we just cannot figure out. We just cannot make out who is talking, what. ఎవరేం మాట్లాడుతున్నారు అర్థం కాదు. అలాగే సిమిలర్లీ when many transmitting baseband info signals, baseband information signals, they get mixed up, and there is no way, we have no chance to distinguish between them, అంటే ఇక్కడ ఉద్దేశం ఏంటి అంటే అన్ని రేడియో స్టేషన్స్ కి సేమ్ ఫ్రీక్వెన్సీ ఉంటే ఓవర్లాప్ అయ్యడానికి ఛాన్స్ ఉంటుంది. సో ఆ ప్రాబ్లం లేకుండా ఉండాలి అంటే radio station or TV station that you take, definitely it need to have a frequency range. So that is the only solution. So that's why we are writing the possible solution. The possible solution is communication or communicating at a higher frequency. And within the boundaries of some frequency. So that means a band of frequency. A band of frequency should be given. A band of frequency should be given to each of transmitter. So this is usually done. In TV and radio stations. అంటే వాటికి మనం పర్టికులర్ ఫ్రీక్వెన్సీస్ అనేవి ఇస్తాం. సో టీవీ రేడియో స్టేషన్స్ లో మనం పర్టికులర్ modulation. Already we studied about the modulation. So it is the superimposing of low audio frequency baseband signal, baseband message with a high frequency wave, and usually we will call this as carrier wave. అంటే మనం మాట్లాడే తక్కువ ఫ్రీక్వెన్సీతో ఉంటుంది కాబట్టి అది ఎక్కువ డిస్టెన్స్ వెళ్ళలేదు కాబట్టి ఇట్ హ్యాస్ లెస్ ఎనర్జీ టు ట్రాన్స్ఫార్మ్ దట్ ఎనర్జీ, that wave from one place to another place. We will take the help of a wave, carrier wave, and by adding these two we are going to get a resultant wave. The resultant wave is called as modulated wave. Modulated wave, which is to be transmitted. So here we have three kinds of modulation. So we are taking types of modulation. So the first one is amplitude modulation. This is very famous. Amplitude modulation. It is called as AM. And the second one is called as frequency modulation, that is FM. And the third one is phase modulation. So majorly we are having questions only from AM, that is amplitude modulation. So this is in our syllabus. So now we will think of amplitude modulation. Amplitude modulation. So now we will understand this. So first we will think of modulating signal. So that means the signal that is going to be transmitted from the another speed, from one place to another place. Maybe our speech. So this is called as modulating signal. And the information matter. This is the message that we are speaking. And next we are taking carrier wave. Carrier wave means it carries our message signal from one place to another place. It have a fixed frequency with no variations to it. So this is about carrier wave. And after taking or after considering amplitude modulation, so we are going to see so this will be the AM signal. So this is the amplitude modulation signal. So in this way, we are having amplitude modulation. So now we will analyze how the wave is going to be modified, and we will think of the terms. So here the most important point is in amplitude modulation AM, the amplitude of carrier wave, the amplitude of carrier wave is varied according to amplitude of modulating signal, but the frequency of AM wave, kept same as that of carrier wave. This is very important point. So that means the output frequency is same as that of carrier wave frequency. Only the amplitude changes. So this is very important. So first we think of modulating signal. So that means this is nothing but message. Simply we will call it as message. M of t equivalent to just I am writing AM into sine omega n into t. So here AM is nothing but amplitude of message signal, or modulating signal, and omega n is the respective angular frequency of message signal. So this is very important. AM into sine omega n into. So next we have been speaking of carrier wave signal. So C as a function of time we are taking. So that equal to AC into sine omega c into t. Here AC means amplitude of carrier wave, and omega c is the angular frequency angular frequency of carrier wave. And the most important thing is the resultant amplitude we are speaking clearly. The resultant amplitude, let us say A equal to AC plus AM into sine omega m into t. So this is very important. So that means only after modulation, the amplitude of the wave has been changed. ఇందాకే మనం చదివాం ఫ్రీక్వెన్సీ అనేది మారదు క్యారియర్ వేవ్ ఎంత ఫ్రీక్వెన్సీ ఉంటుందో అవుట్పుట్ కూడా అంతే ఫ్రీక్వెన్సీ ఉంటుంది బట్ ఓన్లీ ఏం చేంజ్ అవుతుంది ఆంప్లిట్యూడ్ ఆఫ్ ద రిజల్టెంట్ వేవ్ చేంజెస్ ఆంప్లిట్యూడ్ ఆఫ్ ద రిజల్టెంట్ వేవ్ చేంజెస్ అంటే ఏం ఉండాల్సినటువంటి ఆంప్లిట్యూడ్ కాస్త ఇలా మారుతుంది ఏసీ ప్లస్ we will take like this AM, AC plus AM into sin omega t. And finally, we are taking modulated carrier wave. So this is very important, modulated carrier. So you need to be very keen in understanding from now onwards. We will write A into sin omega c into t. Just now we discussed the output carrier wave have same frequency as that of carrier wave. Modulated carrier wave having same frequency as that of carrier wave. So that's why we are writing A into sin omega c into t. So A means we will write, just now we studied AC plus AM into sin omega m into t into, this is sin omega c into t. Or I'm taking AC as common, AC into 1 plus AM by AC into sin omega m into t into sin omega c into t. So here, this is very important. Mu is called as AM by AC, and this mu is known as amplitude modulation index, or simply it is called as modulation index. Suppose in the case of FN, I'm speaking, in the case of FN, so the modulation index will be frequency of modulating signal by frequency of carrier wave. ఇలా మనం ఆలోచిస్తాం. Similar formulas we are having. So this is clearly amplitude modulation index. So clearly this is frequency modulation index. సో దీన్ని ఈజీగా గుర్తుంచుకోవచ్చు మ్యూ ఎం ఒకేలాగా ఉంది అంటే ఒకవేళ కన్ఫ్యూజ్ అవుతే ఏసీ బై ఏఎమ్మా లేదా ఏఎం బై ఏసీ అనేది కన్ఫ్యూజ్ అవుతే సో సింప్లీ వి విల్ రిమెంబర్ దట్ మ్యూ ఎం సిమిలర్గా ఉన్నాయి సిమిలారిటీ అనేది కాస్త ఉంటుంది ఎం సో ఇన్ దట్ వే వి విల్ రిమెంబర్ దీస్ ఆర్ వెరీ ఇంపార్టెంట్ ఫార్ములాస్ సో దీస్ ఆర్ వెరీ ఇంపార్టెంట్ ఫార్ములాస్ ఓకే after taking this we will continue our derivation. CMF is equivalent to, so after taking the expansion, so from here we are taking the expansion equal to AC into sin omega c into t plus mu into AC into sin omega m into t sin omega c into t. Or finally, we have AC, amplitude of carrier wave into sin omega ct plus it can be written as mu AC by 2 into 2 sin A sin B can be written as cos of A minus B minus cos of A plus B. That's only we are writing omega c minus omega m into t minus cos of omega c plus omega m into t omega m into t here. And here we are going to discuss the most important things. So they may ask what is the maximum amplitude, as you are using two waves, one is carrier and the one is modulating signal. So the A maximum is AC plus AM. So if they ask about the minimum amplitude in the wave, if we see what is the minimum amplitude in the modulated signal, the output. So that we will write it as AC minus AM, AC minus AM. And here we have two frequencies, omega C minus omega M, and as well as omega C plus omega M. This omega C minus omega M and omega C plus omega M. So these are called as sideband angular frequencies. So these are really very important, sideband angular frequencies. So that means angular frequency, lower sideband we are taking. So that equivalent to omega C minus omega M, and the upper sideband equivalent to omega C plus omega M. So that means whenever a communication signal having a frequency range, so this is the starting point and this will be the ending point of. So that means we have the message signal in between these two waves only. అంటే ఈ రెండు ఫ్రీక్వెన్సీస్ మధ్య ఉండాలి. ఇది స్టార్టింగ్ పాయింట్ ఫ్రీక్వెన్సీ, ఇది ఎండింగ్ పాయింట్ ఫ్రీక్వెన్సీ ఉండాలి. So now we are taking a graph for this. So let us see. Okay, this graph is very important. Suppose I am taking this will be the omega of carrier wave, and this is omega C minus omega M, omega C minus omega M, and this is omega C plus omega M. So that means on the x-axis we are taking angular frequencies, on the y-axis we are taking amplitudes. So here we are speaking about the carrier wave having a frequency AC. And this is the output modulated signal we are speaking. It have an amplitude mu AC by 2. Okay, so clearly we see this is the lower sideband frequency and this will be upper sideband frequency. So that means clearly, so we need to understand. So every communication should be present between the LSB and as well as SB. So this is known as bandwidth. అంటే ఆ ఫ్రీక్వెన్సీ రేంజ్ లోపలే మన కమ్యూనికేషన్ అనేది ఇవ్వాలి. సో అది మనం చూస్తాం. అండ్ సో లోయర్ సైడ్ బ్యాండ్ ఫ్రీక్వెన్సీ అన్నారు అనుకోండి, లోయర్ సైడ్ బ్యాండ్ ఫ్రీక్వెన్సీ. So that is FLSB, omega by 2 pi. So that means omega LSB by 2 pi. Omega LSB by 2 pi. That equivalent to omega C minus omega M by 2 pi. And then we are speaking about upper sideband frequency. Upper sideband frequency. So we take F into USB equivalent to omega USB by 2 pi. Or else we will write omega C plus omega M by 2 pi. And the most important thing is bandwidth. So here we are taking bandwidth of AM wave. Bandwidth of AM wave means that is the difference. Delta omega is equivalent to omega of upper sideband frequency minus omega of lower sideband frequency. So by substituting this, we will get 2 omega M. Actually, in the output, to avoid distortion, so that means to avoid distortion, the modulation index is less than or equivalent to 1. So here we are taking total power. So we are taking the last few formulas for the communication system. Total power total power of AM wave. So that is output. We are writing PT is equivalent to PC into 1 plus mu square by 2, where already we know this mu is the modulation index and the PEC is the carrier wave power, and PT equal to PM into 1 plus 2 by mu square. So here PC is the power of carrier wave and PM is the power of modulating signal, that is input. So next we have been speaking about the fraction of power, fraction of useful power, fraction of useful power that produced, that produced. So useful power means, so we need the signal actually. So therefore PM by PT we will use message signal power by transmitted power, total power, that equal to 1 by 1 plus 2 by mu square we are having. Because so in the output the message is important. Actually our total aim is to convey the message only. So that's why PM by PT we are writing. So useful output is nothing but PM by PT. And the next one we are speaking fraction of power carried by power carried by side bands. So that is nothing but PC by PT we are speaking. So that equal to 1 by 1 plus mu square by 2. PC by PT equal to 1 plus mu square by 2. We have been. And similarly, from these formulas, also we will write from these formulas, IT equivalent to IC into root of 1 plus mu square by 2. Because I is proportional to root P, so from there we are writing. IT is total. Total means output. Modulated current. Modulated current. And IC is carrier current. Carrier current. So that is unmodulated. And finally, we are speaking if carrier wave modulated, by several message signals. It contains several message signals. Then, so we are taking the modulation index for several process or several message signals. Mu equal to root over mu1 square plus mu2 square plus up to so on. Mu1, mu2, mu3 up to so on are the modulation index for respective signals. And this one is very important. If A maximum and A minimum are maximum and minimum amplitudes of modulated carrier wave, that is output, modulated carrier wave, then we are saying percentage of modulation, then percentage of modulation. So nothing but mu into 100 we are speaking only. So mu into 100 means simply we will say A maximum minus A minimum by A maximum plus A minimum into 100. And we know that already we see in AC is equivalent to A maximum plus A minimum by 2. AC equivalent to in the AM equivalent to A maximum minus A minimum by, and this is very important. So that is total number of channels accommodated for transmission, ఫర్ ఎగ్జాంపుల్ మనం ఇన్సైడ్ 3A సాటిలైట్ ని పంపించాం అనుకోండి, దానికి స్టార్టింగ్ టు ఎండింగ్ కొంత ఫ్రీక్వెన్సీ రేంజ్ అనేది ఉంటుంది. సో ఆ ఫ్రీక్వెన్సీ రేంజ్ లో ఎన్ని ఛానల్స్ పడతాయి, ఎన్ని ఛానల్స్ ని మనము హైట్ ఇవ్వచ్చు, లెంత్ ఇవ్వచ్చు అనేది మనం చూస్తాం. సో ద నెంబర్ ఆఫ్ ఛానల్స్ అకామిడేటెడ్ ఫర్ ఎవ్రీ ట్రాన్స్మిషన్. అంటే సింపుల్ గా చెప్పాలి అంటే ప్రతి శాటిలైట్ కి కొంత ఫ్రీక్వెన్సీ రేంజ్ ఉంటుంది. ఆ శాటిలైట్ లో ఉన్న స్పేస్ కొన్ని టీవీ ఛానల్స్ కి లీజ్ ఇస్తారన్నమాట. అంటే మనకున్న బ్యాండ్విడ్త్ అంటే ఆ లిమిట్, ఆ రేంజ్, ఆ గ్యాప్, ఫ్రీక్వెన్సీ రేంజ్ ని మనం బ్యాండ్విడ్త్ అంటారు. సో దాన్ని ఎన్ని ఛానల్ కి షేర్ చేస్తాం అనేది ఇప్పుడు మనం చూస్తున్నాం. నెంబర్ ఆఫ్ ఛానల్స్ అకామిడేటెడ్ ఫర్ ట్రాన్స్మిషన్. సో దట్ ఈక్వల్ టు టోటల్ bandwidth of channel by total bandwidth of channel by bandwidth per channel. And ఒక్కొక్క ఛానల్ కి ఎంత స్పేస్ అవసరం అవుతుందో చూసి టోటల్ స్పేస్ బై ద స్పేస్ రిక్వైర్డ్ బై ద ఛానల్ మనం చేస్తాం. అండ్ this allowable frequency range for any channel lies between FC minus FM and FC plus FM. అంటే ఏ ఛానల్ తీసుకున్నా సరే అది LSB UFP మధ్యలోనే ఉండాలి. లోవర్ సైడ్ బ్యాండ్, అప్పర్ సైడ్ బ్యాండ్ మధ్యలోనే ఉండాలి. సో దిస్ ఈజ్ అబౌట్ కమ్యూనికేషన్ సిస్టమ్.